What's up, ladies and gentlemen? It's Ryan here, and today I want to talk about 3 advanced concepts in Golang. So we're going to talk about channels, context, and interfaces. These are tools that you can use to make your code cleaner and more maintainable, especially as your project grows in complexity. So let's start off with channels. So channels are used when you want to transfer data between different goroutines. So what we can do is say data_chan equals make chan int. So what this does is it makes a channel of type int, but this could technically be float or string, or if we have our own data type here, then we can even use that as well. So with the channel, we can do 2 things. We can send data to the channel. So here we're going to send the integer 789 into the channel. And then we can also receive data from that channel. So we're going to say n equals the value inside the channel. And then in the end, we can print this. And let's try to run this and see what happens. Okay, so it's giving us a deadlock. So why is it giving us a deadlock? Well, we sent the value to the channel, and then we received a value from the channel. So the thing is, by default, a channel does not have any space inside of it. You cannot temporarily store a value inside of a channel. A channel is sort of like a portal. So if you're going to have data enter the channel, it also has to be able to exit the channel simultaneously, not before or after, but literally at the same time. So if I actually comment one of these out and I run it, then it's still going to be a deadlock. And if I comment this other logic out and then I run it, okay, it still turned out to be a deadlock. So both of these lines actually have to execute simultaneously. And the only way for that to happen is on different goroutines, right? So if we do go func, so now we have them running on different goroutines, which means they can execute simultaneously. So now we run it, and yeah, n equals 789. Everything works as expected. So this is the thing about an unbuffered channel, is that this channel has no space inside of it. It's like a portal. You have 2 parts of a portal, the entrance and the exit. And if you just have an entrance and you don't have a destination, then it's just going to block and it's going to deadlock. So in the end, you have to have one thread that's adding data to the channel. And then simultaneously, you have to have one thread that's receiving data from the channel. So let's go back to the old code for a second. So this code, if we run this code, it fails due to a deadlock, right? Because the channel has no space inside of it. So technically you can actually make this into what's called a buffered channel, where you can add space to it. And now if I run this, it runs fine. So if you turn this into a buffered channel, then you can temporarily store a limited number of values in that channel before you receive it. But in this case, I'm going to try to add 2 values and let's see what happens. Well, it fails due to a deadlock on line 10, and it's failing because I only have space for 1, and yet I tried to add 2. And so if I make this 2, now it works fine. Then we can copy this logic here to receive 2 values from the channel as well. 789 and 123. So this is the most rudimentary example of what you can do with a channel. But it's not necessarily the way channels are meant to be used. Channels are meant to be used in a multi-threaded context, right? It's meant to be used with different goroutines. So let's go over how that looks. Okay, so now we're back to ground zero. We have our data_chan, a channel of type int, and it's unbuffered. So what we can do is say for n in range data_chan, and I'm going to just print the value. And this is another syntax you can use to grab values out of the channel, which is pretty neat actually. And if we try to run this, of course, it's going to deadlock because we're trying to receive data from the channel, but we haven't sent data to the channel, right? The rule is if you want to receive data, you have to simultaneously send data to the channel. So func, and we're just going to have a loop here. For each iteration of the loop, we're going to add the value I into the data_chan. So it's going to go through the loop 1,000 times and add the value I into the data_chan. And simultaneously, we're going to consume data from the channel and then print it out here. So this is running on a background thread while this is running on the main thread. And so if we go ahead and run this, so if we scroll through, it looks like it actually did go through all the iterations, except at the end it said deadlock. So what happened is it went to 999, it sent the data, and then it went here to line 12 and it exited the goroutine. The goroutine was done at this point. There was nothing to do, except here on the main goroutine, it was still trying to receive data, even though there was nothing to receive, and that put it in a state of a deadlock. So all we have to do here is after we're done sending the data to the channel, we do close data chan. And if we run this again, now it does all the iterations and it terminates fine without a deadlock. So this is another way that we can use channels. So let's go ahead and make this into a more realistic example. So I'm going to have a function called doWork, and it's going to return an int. And inside of it, I'm going to do time.sleep for 1 second. And I'm going to have it return a random integer up to 100. So we're going to pretend that we're doing a whole bunch of hard work here, but really it's just sleeping for 1 second and then returning an integer. So what we're going to do here is on each iteration of the function, I'm going to do result equals doWork. And then I'm going to add the result into the data chan. Now we're going to actually do some work. So let's run it. Okay, so what's happening here is it seems to be waiting 1 second for each one of these operations, which is not what we want, right? The whole point is to go faster. So what we want to do here is actually wrap this in a goroutine. So go func. So now it's a tiny bit more complicated because for each iteration of the loop, it's going to create a new goroutine. And that's what we want, but now we have to track whenever these goroutines are done so that we can wait for them to complete. And for that, we're going to use a wait group. On each iteration of the loop, we're going to add 1 to the wait group. And then inside the goroutine, we're going to defer wait group.done. Then in the end, we're going to wait until all the iterations are done before we actually close the channel. Okay, so now let's run it and see what happens. Okay, so it seemed like it took about a second, but then it went through all 1,000 iterations and got it done. So what's really cool about this is even though we had 1,000 different goroutines, all of that data was sent to one channel and we were able to receive it at this one point of entry. So this is an example of how you can use channels to manage the flow of data between your goroutines. So I've seen some very sophisticated examples of channels out on the web and on YouTube, and there's some really cool stuff you can do with channels, but you also got to be careful because it's easy for it to get out of hand. Channels are really cool and fun to use, but they're not always the best tool for the job. Sometimes a simple mutex will get the job done in a much simpler way. But nonetheless, it's good to know how to use channels because there are certain third-party libraries that use them, and you will eventually find a time and place where it becomes a useful asset. All right, so now let's talk about context. So context is a way for you to add a timeout or a cancellation to a goroutine. Let's say you have some long, expensive operation that takes 30 seconds to complete. Well, you might want to add a way to be able to cancel that halfway through, and context is one way for you to do that. So here I have an example of some logic. So here we create an HTTP request. It's going to make a request to this URL. Now this URL, if I actually check it out, so this is what comes up. It's just a placeholder image, 2000 by 2000. And so that's what we're going to download with this code. So we create the HTTP request, perform the HTTP request, and then we print the size in bytes of that data. So pretty simple stuff that we have here. Let's go ahead and run the code and see what happens. Okay, so it says it downloaded the image of size about 7 kilobytes. So let's say we wanted to cancel this request if it takes longer than a certain amount of time. Well, in that case, we can use context to add a timeout to that request. So we'll say timeout context equals context.withTimeout. It wants a parent context, so we can just do context.background. Then it wants the duration. So I'll say time.millisecond times 100. So we'll give it 100 milliseconds. And also it returns something called a cancel function. And what we got to do is defer cancel. So what this cancel function does is it actually cancels the timeout. It's the equivalent of doing clear timeout in JavaScript. So now instead of http.newRequest, we can do http.newRequest with context and then pass the timeout context. So a lot of libraries have this built in where they will accept whatever context you give it, and that way you can add your own timeout or cancellation to it. Now let's run the code again, and it says there's an error, context deadline exceeded. Now if I bump this up to, let's say, 700 milliseconds, okay, now it's fine. It's downloading within that amount of time. If I bring it back to 50 milliseconds, okay, context deadline exceeded. So we can see that it seems to be working, that if it takes longer than this amount of time for the HTTP request to finish, then it will throw an error and cancel. So this is one way that you can use context. So here's another example of how you might want to use context. So if you're using Go to run a gen server, then here's an example where I have a GET request to the /hello endpoint. And I'm performing a lot of the same logic as before, right? New request with context. This time I'm requesting the page for yahoo.com. I'm going to grab all that HTML data and then pretty much send that back to the client. Then I'm going to go ahead and make the HTTP request. It took about 3 seconds, but it did eventually come through with all of that HTML. So one thing you'll notice here is I'm passing in context.request.context. And it says this returns the request context. And it says for incoming server requests, the context is canceled when the client's connection closes. So we can test this out. Send, I'm going to cancel. And we can see that it did actually throw an error. It says context canceled. And so it immediately just canceled this entire request. So that means that here it didn't waste any time doing any additional logic. It just canceled the HTTP request itself. This is a great way to make your apps more efficient so that they're not doing more work than they need to. So I can actually take advantage of the built-in request context, but then I could add my own timeout on top of that. So I could say timeout context equals context.withTimeout. And here it wants a parent context. So I could use the original request context as the parent context. I could say time.second times 2. It wants cancel here, so defer cancel. Then here we can use the timeout context. So what we have here is we created our own context that is a wrapper around the request context with a timeout of 2 seconds. And we pass that to our HTTP request. So now if we make a request, I can see that after about 2 seconds, that's when it threw an error and said, hey, context deadline exceeded. So using this pattern is a way that we can preserve the original behavior of the request context and wrap that in our own worst case scenario timeout. So if the request doesn't cancel itself within a certain amount of time, then we can cancel it ourselves with our own timeout. All right, now let's talk about interfaces, which is the easiest part and also my favorite part of Golang. So interfaces allow you to basically write a blueprint for how your app is going to behave. If you're familiar with object-oriented programming, then you pretty much already know how interfaces work. But because Golang doesn't have like true object-oriented programming and inheritance and all that, then interfaces gets you at least a step in that direction. And it especially makes it easier for other engineers who want to jump in and understand what your services actually do. So let's use a real world example in this case. Let's say we're creating a banking application. So an app that allows you to manage multiple bank accounts, but not just one type of bank account, but multiple types of bank accounts. Let's say a user might have a Wells Fargo bank account, a Chase bank account, and a Bank of China bank account, some international Swiss bank accounts, maybe even a Bitcoin account. And all of these are very different in terms of the APIs that you would use to be able to interface with them and stuff. But all of these accounts have a few things in common. So I'm going to say type bank account interface. So first I would want to get my balance, and let's use integer. Let's say 100 equals $1. So this represents cents. And I know I want to be able to deposit money into my account, so a certain amount. And I know I want to be able to withdraw a certain amount as well. And this might throw an error because I might withdraw too much. So these three methods pretty much represent what any bank account can do, whether it's Wells Fargo, Chase, Bitcoin, this or that. You're going to be able to talk to all of these bank accounts by using the same interface. So now let's create different types of bank accounts. So first I'm going to create a Wells Fargo bank account, type Wells Fargo. And depending on the IDE that you're using, you might have some functionality like this, where your IDE will automatically fill in these methods for you. And so that makes it a lot easier. So now this Wells Fargo struct implements the interface for bank account because it has all of the matching methods. So I know I'm going to have a balance here. That's an int. I'm also going to create a constructor for this. So we got a balance, we got a constructor that initializes this. And now we can add the actual implementation for what it means to get a balance or deposit or withdraw. So first I'm going to change these to pointer receivers because I am going to modify the underlying data. For getting the balance, all we have to do is literally say return w.balance. So for the deposit, we're just going to say w.balance plus equals the amount. So for withdrawing, we need to be a little bit careful because we don't want to allow the user to withdraw too much unless their name is Ryan, right? So we want to say new balance equals the old balance minus the amount. And if the new balance is less than 0, then we're going to return an error here. Insufficient funds, I guess that's what they say nowadays. Otherwise, we do w.balance equals new balance and return nil because there is no error. So now we have fully implemented a Wells Fargo bank account. So here at the main function, I went ahead and instantiated a new Wells Fargo account. I deposited 200 into that. I grabbed the current balance and then printed the balance. So if we go ahead and run this, it says WF balance is 200. Cool. And let's add a little more chaos to this. Let's say 100, 370, and we'll do a withdrawal at the end of 117. We should technically acknowledge the error for this. And now let's run it and see what happens. So in the end, it says the balance is 553. So it looks like everything's working okay. So this is cool. I have one type of bank account that fits this interface, but that doesn't really show the true power of interfaces. So I'm going to actually create another type of account called BTC, and this is going to be Bitcoin. And I'm going to say type Bitcoin account struct. And like before, it has a balance, which is an integer. And like before, I'm going to let my IDE auto generate these methods for me, and also change these to pointer receivers. And same situation, return b.balance to deposit. I'm going to say b.balance plus equals the amount. And withdraw, I'm going to copy and paste that original logic from Wells Fargo. Now we have a Bitcoin account. I'm going to go ahead and add an initializer. So I just added an initializer to create a new Bitcoin account. I'm going to have a balance of 0 to start off with. And for this one, I actually want to make it a little bit different. I want to add a fee. So we're going to say that the fee is, let's say 300, which is 300 cents. That's going to be $3. And anytime you want to withdraw money, it's going to be the original balance minus the amount minus the fee as well. So if we compare the Wells Fargo account here, the withdrawal, we only withdraw the amount. But then for the Bitcoin account, we're going to withdraw both the amount and the fee. So these two different accounts are very similar in what they do, but there's just one little difference in implementation. So this is where the power of the interfaces really comes in. So I could say my accounts is an array of bank account. And just for a little bit of clarity, you might want to use a prefix and call this iBankAccount just to be clear that it is an interface. MyAccounts is an array of iBankAccount. And I'm going to add a new Wells Fargo here and a new Bitcoin account. Cool. And now I can iterate over this. I'm going to say for account and range my accounts, account dot get balance, say balance equals get balance. And then I want to print F. So what's cool about this is here's a list of all my accounts. And as far as typing is concerned, we're using the interface as the type. And this allows us to treat all of these as pretty much the same thing. So I can iterate over all of these accounts, get the balance for it, and then print that out. And if I do that, it says balance is zero, of course. So let's mix it up a little bit. I'm going to do account.deposit 500 and then account.withdraw 70. And if there's an error for the withdrawal, then I'm going to print the error. Okay, so let's go ahead and take a look at this. Okay, interesting. So it's saying the balance for my first account is 430 and the balance for my second account is 130. And so you can see that we're performing the same operations against all these accounts, and these are treated as the iBankAccount type. But because these bank accounts behave a little bit differently in their implementation, that's the reason that I'm getting a different balance here. So what's nice about this is if another developer comes in and sees this, then they know exactly all the things that an iBankAccount can do. And also the future you that looks at this code in 3 months or 3 years later, it makes it easy to jump back on board and quickly understand what the code is doing. All right, so that's it for today, ladies and gentlemen. I talked about channels, context, and interfaces. These are 3 advanced concepts in Go that will level up your code, make your code a bit more clear and easier to maintain as your projects grow in complexity. So hey, if you liked the video, please like and subscribe and support a little YouTuber like myself. Thank you for watching.